Good evening. I am Salla Pupponen, and I have the honor to present our exciting research tonight here in the Helsinki Challenge Award Party. We are Team Heatstock, and we want to bring the summer's heat into the wintertime with our novel long-term heat storage solution. Heating energy accounts for over 50% of the global energy consumption today. All the heating energy could be easily provided with solar energy. Its annual potential is roughly 3 times larger than the total energy consumption. Still, less than 1% of the heating energy is produced in a renewable, emission-free manner. The primary problem of renewables is their intermittency. The sun doesn't always shine. To address this problem, we need efficient energy storage technologies. Heat can be stored by hot water tanks or by so-called phase change materials, which store and release heat by melting and crystallization. However, the current technologies are not efficient but require huge storage volumes for long-term storing of heat. We have invented completely new type heat storage material. Our solution utilizes also melting and crystallization for heat storing and releasing. However, the heat storage properties of our technology differ drastically from the conventional ones. When you cool water below 0 degrees, it starts to freeze. Liquids crystallize when cooled. Our material works in a completely opposite manner. It crystallizes only when heated. By exploiting this unique and abnormal property, we can store crystallization heat for the first time at low temperatures and as long time as wanted. We have got extremely promising results from our lab-scale measurements. If we win, we will optimize our solution further and build first pilots together with industry. We need science, we need creativity, and we need courage in order to make true changes in our ways of living. With your support and collaboration, we can make some of these changes. Thank you.
Well, that's literally taking the sun into the middle of the Finnish winter.
Oh, thank you.
I'd like to have that. Do we have any questions? Hands up.
Everything is clear.
Thanks, Seppo von Futurena. How do you scale this up? So, I mean, how do you get the material and how to make it in large quantities to really serve the purpose for the whole society, or as part of it?
Yeah, good question. Well, now we are on a stage that we move from labs, from analysis scale to, let's say, 100 gram or half kilo scale. And that we can do in lab relatively easily. The pilots, they might be, for instance, 10, 20 kilogram unit that we put to, for instance, store waste heat of some industrial processes. If we already succeed in this level, then we can really say that our technology really works, and then we can move into the larger amounts.
So there was a question that was...
Energy density, I heard, yeah.
The capacity, yeah.
Capacity, yeah. It's about 50-60 kilowatt hours per cubic meter. So it is actually really high energy density. We have calculated approximately that if you have a passive house in southern Finland, a 100 square meter passive house in southern Finland, to store energy to heat this house for half a year, it would take approximately 12 cubic meter storage. It's still, of course, large space, But if we compare it to old solution, what would be basically heating water, so huge water tank, the size of the water tank, which should be really, really well insulated, would be actually 300 cubic meters. So it is much, much smaller volume. And the materials are affordable.
There's a question over here.
Are there any health hazards in the material you're using, or ecological hazards in the case it leaks into the environment? And is it energy sufficient to produce it and easy to dispose of?
Good questions again. No, there are no health hazards. Our materials, basically, the active material is a sugar alcohol that you can eat. So not that dangerous stuff. And then the additive that we use is actually a polymer that is used in diapers. So again, not hazardous at all. About the production costs, I don't know if you asked about those. Well, I know that the materials are relatively affordable, but of course, if we need them in larger quantities, then the price goes down. So of course, I cannot say any price for this unit, but the raw materials are really affordable, and the making of the material itself is really simple.
All right, then I will take the time and I will ask the same question.
Oh my God.
Could you share with us some really insightful learning experience that you've had during the year?
It's basically a bit similar that Leona said. I'm chemist, so I'm used to work alone in a lab, doing my own stuff. And I somehow figured that that I'm a lonely geek and no one is interested in my stuff. And it has been so much fun and really, really interesting to hear that people are actually really interested into science. And I have been so enthusiastic about this. Yeah.
Thank you. That's
Thanks.
really good to hear. Thank you,
Thank you.
Heatstock.